In this video, we'll show an example of how to divide an algebraic expression by a monomial. We want to divide the polynomial 8ab plus 32a to the power of 4 b squared by the monomial 16a cubed b squared. The first step is to distribute the monomial to divide each term of the polynomial. This gives the following sum of fractions. The second step is to divide the coefficient of each term, then the common variables. First, divide the coefficients of the first term. 8 over 16 equals 1/2. Then, applying the law of exponents, subtract exponents that have the same base. For the variable a, 1 minus 3 equals -2. For the variable b, 1 minus 2 equals -1. Follow the same steps for the second term. Start by dividing the coefficients. 32 divided by 16 is 2, which becomes the numerator. Then, subtract exponents that have the same base. For the variable a, 4 minus 3 equals 1. For the variable b, 2 minus 2 equals 0. This answer is correct, but it can be simplified further. Variables that have an exponent of 1 can be simplified. A to the power of 1 is equal to a. Also, for the last term, b to the power of 0 is equal to 1, so it can be removed completely. We must also ensure that the mathematical convention of not leaving negative exponents in an algebraic expression is respected. Negative exponents are simplified using the property in which a base with a negative exponent is equivalent to the reciprocal of the base with a positive exponent. For example, x to the power of -2 has the same value as 1 over x squared. If one of the factors placed in the numerator is assigned a negative exponent, it is placed in the denominator with the same exponent, but positive. The opposite is also true. Going back to the first term in the expression, the variable a has the exponent -2. Therefore, it must be lowered to the denominator and written as a power of 2. Still in the first term, the variable b has the exponent -1. It must be lowered to the denominator. The exponent becomes 1. As you know, writing exponent 1 is unnecessary. The final outcome is therefore 1 over 2a squared b plus 2a. I'm going to repeat the second step of our example, but in a slightly different way, so there will be no negative exponents. The key is to ask yourself where the biggest factor is, in the numerator or the denominator. For the first term, divide the coefficients as you normally would, which gives 1/2. For variable a, notice that there is a 1 on top in the numerator and a 3 on the bottom in the denominator. So, instead of subtracting the exponent 1 minus 3 in the numerator, subtract 3 minus 1 in the denominator, which equals 2. In other words, we subtract from where there is more. This way, you automatically get a positive exponent in the correct place. For variable b, it's the same thing. Subtract 2 minus 1 in the denominator, and rather than in the numerator. This gives b to the power of 1, or just b. For the second term, do the same as before. The final answer is still 1 over 2a squared b plus 2a. There is often more than one approach when faced with a mathematical problem. Choose the way that works for you, but remember to respect mathematical conventions.